Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today I'll show modeling and assembly of a condenser used in an air conditioning system. Let us start modeling from the parts itself. It is consisting of 4 to 5 different parts. First of all, we'll make the side plate. It is consisting of 2 side plates and fins. First of all, we'll make the side plate in a right plane. Sketch. Let us start on rectangle. Can provide smart dimension to this one, as this one will consider as 400 millimeter, and width will be 100 millimeter. In between we have to provide the holes. Let us provide holes. Smart dimension to this one. Let the diameter be 15 millimeter. And the distance from both the edges is 25 millimeter. On the other side also we can make another one. Let us provide smart dimension to this one. Diameter will be 15 millimeter. Let us make the distance as 50 millimeter. And from side it will maintain the same distance as 25 millimeter. At the same location we can make another hole, that is for strainer. Let us make the strainer diameter as 10 millimeter. And the distance from top edge it will be 25 millimeter. Done. Again from side also it will be same distance. Done. Now we can do one thing, like we can go for series of these circles along this edge, right? So for that we have to provide linear sketch pattern. To select the y-axis, this one we have to make it off, and at a distance of 50 milli we have to make 8 numbers of holes are required at a distance of 50 millimeter. Now let us select that hole. So, and here in this case, first one we have to make it 1. So we made 8 numbers of holes at a distance of 50 millimeter. Done. Similarly, from here also we have to make the same thing. In that case it will be 7 numbers. Let us select that one, and we are providing linear sketch pattern in y direction. Along x it will be 1 only. We don't want anything along x direction. Along y direction we want to make 7 numbers at a distance of 50 millimeter. You can check. Done. And again the small one we have to make it this side, that is the strainer. We can make the strainer here at this location. The diameter will be 10 millimeter like the previous one. Done. Now other dimensions are not required, we have already maintained by tracking. This one 25, and again from the side also it will be 25. So it is ready. Green check. Exit from the sketch and extrude that one. Select the sketch again and features, extrude boss base. As I've told that this one will be the side plate, so what we have to do is we are planning to make the thickness of this one maybe 5 mm. Green check. And again you have to provide some kind of rectangular part at this location. So to draw some rectangles, sketch. Now to complete that sketch you can provide relations. These two are collinear, and let us provide that distance equal to 25 millimeter. Sketch is complete, so exit from the sketch and features, extrude boss base by 5 millimeter. We can save this part. This is the front plate. We can save it by the name of side plate 1. Save it. Now we have to make the second plate with the same component. We can make the second side plate also. For that we have to delete this part. Let us delete this sketch also. Now we'll do the same thing in the other side, so that will be the another side plate. We can make a sketch, rectangle. Now like the previous case, we can apply relations to complete the drawing. This line will be collinear with the edge. It is okay. Now we can provide smart dimension to this one as 25 millimeter. Green check. Exit from the sketch and select the sketch again. Features, extrude boss base by 5 millimeter. Green check. It is done. So we can save this one again by the name of side plate 2. Done. Next one we have to make the fence, which will be inserted in between these two plates. For making the fence, what we have to do is, let us delete this part, delete the sketch also, and the same thing we can use as the fin. In that case we have to reduce the thickness. Let us reduce the thickness by 2 millimeter. Done. Now we can save it by the name of fin. Done. Now the most important part, that is the pipes should be drawn. For drawing the pipes, we'll try to use 3D sketch, and also we need to have the sketch of this one. So we can delete this solid part and I will be utilizing the sketch of that. Okay, now we're starting sketch with the 3D line. 3D sketch we are starting. A series of this type of lines we can draw with the 3D sketch line without having any specific dimension. We can draw it, and later on we can provide relations to have all these lines equal. Let us make the lines one by one. We have made all the lines. Now we can do one thing. We can use relations to have all the lines of equal length. Let us provide relations to this. All these are having equal length. Green check. Now we can provide smart dimension to this one as 600 millimeter. Green check. Now the thing is, very important part is these lines should be connected. It will be a series of lines with some connectivity. This will be acting as the starting point and this one will be the end point. So we have to join these things in the form of some lines. So we can do something again. We can start with central lines and join alternate lines. Starting with central line. Alternately, we have to use these things. This is a starting line. It will go in this way and come back. So we have to connect these two again. This one and that one. Alternately, we have to connect. So again, we are making some central lines. So we made the lines. Now in between these lines we have to make an arc. We can make it from this arc. Same thing we have to do in the other side also. It is done. Now in between these central lines we can delete it. Other side also we have to do the same thing. Done. Green check. This is the path. We have drawn the path. Now we have to provide a profile to this path. From the swept boss base, circular profile can be provided, but I think it is better to draw the profile again. So for drawing the profile, you have to make a plane perpendicular to this line. So what we'll do is select that end of this line, features, reference geometry, plane. Now we have created a plane, but we have to make a plane perpendicular to this line. So we'll select the line again. Now it will be perpendicular. Okay. On that plane, we have to provide the profile. So plane, normal to, we have to draw from here itself, right? So we're starting sketch. This is one. And this is inner one. We can provide inner diameter as 14 millimeter, and outside one should be 15 millimeter. Green check. Exit from the sketch. Select the sketch again. Features, swept boss base. You have to provide path of this profile. So it is made. Right, you can see. This is our pipes. Now we can hide this sketch. Complete. We can hide this plane. This is our drawing for these pipes. Let's provide material as copper to these pipes. It is done. We can save this one by the name of pipes. Our drawing is complete. Now we have to make an assembly of all these things. So starting an assembly. Assembly. We have to bring all these things by browsing. These are the components. Now one thing we forgot to draw, that is strainer is required also. That is very simple, we can draw it any moment. We can make the strainer. You start from right plane, sketch, circle, smart dimension to this one as 10 millimeter. Green check. Exit from the sketch. Select the sketch again and features extrude boss base. Let us provide extrusion depth as 610 millimeter. Green check. And the top of this one we can provide some bolt. Select the plane, sketch. Let us provide some hexagon to this one. Smart dimension, let us provide the smart dimension to this one as 10 millimeter. Exit from the sketch. Features extrude boss base. We want extrusion of 7 millimeter. Done. Green check. Now on the top of this one we can make another circle. Select that plane. Let us draw one circle. Let us make the diameter as 15 mm. Exit from the sketch. Sketch is selected. Features, extrude cut, and flip side to cut. And angle we will provide 25° angle. You can check it is done. Let us provide the angle a little different. Let's see how it is changing. Let us make the angle. This depth, maybe we will make it little less, 5 mm. The angle will make it 30. Green check. Done. You can provide the material as a brush. You can save it by the name of strainer. And another thing is remaining at the end of this one, knot will be required. Part. Let's start that one from right plane, normal to sketch, hexagon. And inside that one we can draw some circle of diameter 10 mm. Let us provide smart dimension to this one as 10 mm and this 10 mm. Exit. Select the sketch again. Features, extrude boss base, and extrusion depth let us make as 7 mm. Done. Now select that plane again, sketch. Let us draw one circle. Provide the smart dimension to this one as 15 mm. Green check. Exit from the sketch. Features, extrude cut, flip side to cut, and we want to provide an angle of 30°. And here you can make the length 5 mm. Green check. It's done. Again, let us make this material as brass, polished brass. You can save this one by the name of knot 2. Save it. Now all these parts we drag it in this assembly. Insert component. I want to drag the strainer and nut. Done. Now we can start our assembly. For making our assembly, what we have to do is, first of all, we'll make these pipes as fixed and others will be movable. So make this pipe as fixed and others we have to make it movable. This one will be floating. Okay, done. Now starting from mat itself, this pipe should be inserted on the side plate. One constraint is met. Actually, you have to follow 3 different constraints. First constraint is met. We can drag it. Okay. Now one thing can be done, that second pipe also, that means this end will be meeting with this location. So we can do again met. Again check, done. Now the third constraint, this one will be meeting with the back side of the hole. 3 constraints are met. So first one is done. Now it is fixed, it will not rotate. Okay, now what is that fins inside these pipes? So what we have to do is, so starting with mate again, this hole should be inserted at this location. First constraint is met. Now the thing is, we have to provide some kind of relations. That means the distance between these two will be 2 mm, and also this one and that one should be parallel. Okay, the second one can insert. Two constraints are met. Now the distance is required. That means the distance between this side and that side should be 2 mm. You can check. It is done. Next one, we have to do some kind of relations to align all these fins. It will be done within a very short time. Starting with linear component pattern. It is asking the direction. Select that one. The direction, we have to provide these things in this way. So let us provide direction here. Now we want 148 numbers. Let us see how many numbers may be there, and the distance in between them will be 4 mm, because from backside to the other backside it will be 4 mm. Component to pattern, that means the object should be selected. We can select the object from here as the fin. Fin is selected, and we want numbers to be 146. Green check. Now at the end of this one, we have to provide the other plate. Starting with mate, select that pipe, and this hole should be selected again. First constraint is met. Let us see where it is going. You can drag it this side. It has gone inside. We have to find it where it is. It is somewhere else inside. Okay, it is here, right? You can see. You can drag it. Okay, the other one, again the second one, we can select. This location should be mating with this hole. Two constraints are done. Now the third one, we can provide the distance between them. Here to this back side, it will be 2 mm. The distance will be 2 mm. We can provide. Green check. It is done. You can feel that another could be provided, right? No issues, we can provide anytime. This is the end part. Now in between we can provide the strainer, and also we can see back side, the distance what we calculated, it is little more. Now this part we can provide inside, right? We can do anytime. This one we can check it, and let us see the distance. We have extruded outside, we can extrude this one inside. So select that component, open it. We have made one sketch, and that one extruded outside, we can extrude it inside. So we can edit this part. We have extruded opposite direction, we can extrude it inside direction. Green check. Done. Save it, close that part. That will be updated in the assembly itself. Done. Now the same thing can be done for this object also. You can open it. Edit that extrusion. It was extruded outside. We have to change the direction by 5 mm. Green check. We can save it, and that will be updated in the assembly itself. Yes, it will be updated in the assembly. So our model is almost ready. We have to provide the strainers in between them. Now we can drag it here close to that assembly. So starting with mate again. The hole should be selected. First constraint is met. Now the second one, this side should be met with the back side of this strainer. Done. Now another thing is remaining. Two constraints we have met. That means we can make it, this one will rotate. So to make the rotation stopped, we can make this edge should be parallel to this edge. So all the constraints are met. It will not rotate anymore. This is done. Back side of this one we have to provide that nut. Now we can mate it again. Mate. This one should be mating with the nut. We can reverse the direction. First constraint is met. We can see it has gone inside. We can drag it. Now this side should be mating with the back side of this one. Two constraints are met. The third one is required. That means the rotation of this one should be constrained. So select this one and that one. It should be parallel. So rotation is also constrained. Is done. Green check. Another one is required. So what can we do is we can copy this part. Starting with mate again. Mate. This one should fit here in this location. First constraint is met. Now this side should be meeting with the back side of this strainer. Second constraint is also satisfied. Now the rotation of this one should be fixed. Select this one and that edge. It should be parallel. So all the three constraints are satisfied. Green check. Now the back side, the nut should be provided. Again select the mate. First constraint is done. Now this side should be meeting with back side of the nut. Green check. Two constraints satisfied. Now the third one, the rotation of this nut should be fixed. This one and this plane fixed parallel. Green check. Done. Our assembly is ready. You can see here, this is the input location of freon gas and this one is the output. Right? Now we can do some other things like backside you can provide fan. That is very simple because we have provided some space here, no? So at this location we can provide some platform and on that platform we can provide some fan. Okay, done. Some constraints are redundant. Extra constraint we have made, that one we can delete. That's made, that is not required. That extra constraint we made, that one we can delete it. It's not required. Now it is perfect. See, all the constraints are okay. Now from the history itself we can see everything is fine. Okay, this is all about our today's modeling and assembly of condenser. If you like this video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.